All right. All right. Okay. Yeah. So today I'm gonna give like probably 20 minutes of just Python syntax and basically like most of what you need to know to be able to write Lambda functions in AWS. So yeah. Okay. I'll get started. So first, Python is a dynamic language. So the variables in Python do not already have types when you start. So like you can do right, x equals 5, then you can turn around and do x equals 5, and this is all fine, right? Like this is a number, or actually, yeah, the nice little thing int, uh, and this is right here. This would be a string, but then you can reassign anything, like because any variable can hold any type, basically, right? Um, okay, so that's that. All right, next I'll do loops, and loops in Python are pretty interesting. So it's basically like if you know Java, same deal. It's for and oh, you know what? All right, yeah, start with loops. So for and while. So the syntax, right? If you want to run a loop from like 1 to 10, right? So for that would be for I in range 10. So like what is this? So basically, I is your loop index variable, right? It's gonna be same as Java, the one that holds the value, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? But range basically is like an object that you can get new numbers from. So the first time you try to get something from range, it'll give you spit out 0, and then the second time spit out 1, and then it'll keep going until it uses up all the numbers in this object, uh, which is 9, right? 9 is the last one you're going to get because this is an exclusive bound, so 10 will not be included. Right, and just demo this, I can print I. So that's how you print to the console in Python. Press play, and there you go. See, the hello world came from here, and then in the loop, I had the values 0 to 9, right? And so you might think that, for example, if I have a list in Python, so then uh, in Python, the way you make a list is with square brackets. And every like there's all like list, like technically it's like this. There's a type called list, but like Python, the syntax says uh, like intrinsic support for this square bracket syntax. So you can do like so let me just cut this down to 5 to make things simpler. So then I'd be like 1, 0, 1, 2, 3, 4. Right? These are the indices. It'll just give you back the index, right? And then um, actually, I'll do 1 to 5, like 1 to 5. I think makes more sense this way. So say you wanted to loop through that list, right? So if you're coming from Java, right, the way you might do it would be for I in range length of L. So length of L is kind of weird because it's a function that is not like a method of L, right? But in Python, like there's a lot of collections like that will support this special function called len, and this is how you get the length of a list, right? And then if you want to print each element of that list, you might go no, not 0, I, right? And this will do the trick, right? If I try to run this, I got hello world, and then 1, 2, 3, 4, 5, which are the elements of the list, right? But in Python, there's this concept of Pythonic code, which is basically following the idioms and styles of Python. And in Pythonic code, if you don't actually need the index for anything, you shouldn't have this, because I'll just comment this loop out just so we can compare it, right? The Pythonic way to do it would be just for right, I and L, and then print I. Let me use it like J. Let me use J so it's not confusing, right? So I was the index, but then J now will be like the actual elements, right? So you see, like, this code compared to this code is just so much shorter and simpler and easier to read. But then when you run it, right, it does the same thing, and I'm pretty sure it is also faster, right? Okay. And just a small detail about Python, just in general syntax here. Whenever you have a for loop, same applies to if and else. You have the keyword, then, right, you don't need parentheses around your condition or whatever it is that you're passing. And then you have a colon at the end. And in Python, how this works is if you have a colon, anything after this, right, will be enclosed in the for loop. So I could do like print j plus 1, or let's do a negative j, right? Negative j, and if I run this, right, you'll see that this was controlled by the for loop, but then this is also controlled by the for loop. So in Java, right, if you don't have you can write a for loop without the curly braces, but then the for loop will only apply to this first statement here, and then the second statement here, right? Will not will only be happening once, right? And if you want to do what the Java behavior does, so indentation matters in Python. So what you do is you'd so for example, if I don't use J, right, if I change it to something that doesn't depend on the actual loop, if I do this, right, 1C, 2C, 3C, 4C, 5C, right, then if I de-indent this to be on the same level as the for loop, what will happen is, right, the for loop will go print all the numbers, and then at the very end, it will just print C once. Does that make sense? Any questions so far? Someone have a question? Anthony, was that a question? Okay. All right. Okay. So I guess I'll continue. So I'll do a while loop too, just to demonstrate this. So I can do, for example, if I do, let me just comment this out. If I have I as an index, right, and so this would be iterating through a list with while. So if I have I equals 0, I can do while I L bracket I not equal to 5 colon. I'll do I, so print L I, and then and then I would do increment I, right? So because we don't want an infinite loop. So in Python, you do not have a ++ increment operator. Like everything you do has to be with the plus equals operator. So then to increment a variable in Python, you do I plus equals 1, right? And then if I run this, what will happen is, right, it'll print out the first 4, and then Li will become 5, and then it will stop the loop, right? And so I can also do this with a infinite loop plus a break, right? So in Python, there's a Boolean type, and they can either have true with a capital T or false also with a capital F, right? So if I do this, right, it's basically doing the same thing. If li, so if you want to invert, like negate this expression, right? So that would mean you would stop when it equals 5 instead of when it's not equal to 5. And you would just do break like this to stop the loop. And this will be exactly equivalent to what happened previously, right? Okay, that's what I have about loops. And let me just go over real quick, just I'm pretty sure you're all familiar with conditionals, but then in Python, you can do things like, right, if you do if I equals 1, and then like, so pass, what is this? So if you don't want anything inside this if, right? So if in Java, right, like there would be no point to this, right? But you could do like, in Java, you'd be like if I equals 1, and then, right, you could do nothing. And this code wouldn't do anything, but that would still work. Right? I mean, in Python, like this will actually not work if you don't have anything in here, right? So you need something, and then if you don't want anything, you just do a pass. Just pass, don't do anything, right? But then, like for example, if I a more practical, like realistic example would be if I do like print 1, and then in Python, it's not else if. It's a contraction. It's like a syntactic trigger. It's elif I equals 2. That's just else if, except smushed together, right? And then you can do else, and that's the same, right? You don't need it. You don't need the elif, right? You can just do an if and else, just like obvious. And then yeah. So right, just demo this. If I do 2 else print something like food, right? So if I do,
Does Python have continue?
Yes, it does. Yes, it does. Yeah, break and continue are the exact same as in Java. So just without a semicolon, right? And nothing in, as you can see, like I haven't written a single semicolon in Python yet. So all the statements, like you will never need curly braces and you'll never need semicolons. So it's actually kind of nice. Okay, right. So if I have 1, right, if I run this, should print 1. There we go, printed 1. If I change this to 2 now, print again, I get 2. Pretty simple. And like, go to 5, that'll go into else condition and print food, right? Okay, let's see. Next would be, okay, I went over lists a little bit, right? But then I'll go over some more. So then, right, okay, actually I have the list already up there, right? So if let me cut this down just to make it simpler. Okay, so, and this will also like kind of hammer in the fact that Python, like just like Java, uses references instead of like, so that like 2 objects can point to the same object, that idea. So say if I do, right, L, so M, right, M equals L. So this list object in memory, like it doesn't mean that M will be its own list, right? So this, if you change L, those changes will be visible in M, right? Because M is actually, right, at this point, it's just another way to get to this list. So demonstrate that, right? If I do, right, if I print L and I print M, this is pretty obvious that these 2 will print the same thing, right? 1, 2, 3, 1, 2, 3, right? So then, But if after I print L, and then, I change L, right? If M and L were two separate things, right? This, so if I do equals 3, right? So basically what I'm doing is I'm indexing it to L, and I'm setting the first element equal to 3. So then what will happen, right? If these are separate, when you print M, that should not be affected at all, right? But since M and L are actually pointing to the same list, L and M, L will not contain 3 at the beginning, while M will. So actually, like, even if I do it after this assignment, right? If they were different, theoretically, even after this assignment, I don't even have to do it between the prints, right? If I change L after the assignment, if M and L separate, it shouldn't be reflected in M. But as you can see, if I print it out, right, L and M at this point are actually the same, which makes sense because under the hood, M and L are actually pointing to the same like nameless object, which is this list with 1, 2, 3, right? And then the way you would make M distinct from L would be to pass it into the list constructor. This is actually just one of the ways. I'll show you another way. So yeah, if I do this, then as you can see, if I print, right, M, when you do the construction, it copies out all of the elements of L and holds its own copy. So that way, when L is changed, that's not reflected in M, right? And then I personally like this way more. If you can still use the square bracket syntax, but what you do is you do star L. And you might ask, what does this do? Right? Star L basically, like what would happen if I did this? Does anyone know what this does?
Just the brackets?
Yeah, this L with the brackets around it.
I actually don't even know.
Any guesses?
Does it like create a 2D array?
Yes, that's correct, right? So if I do this, M will be a list of lists with one element, which is L, right? So if I print it out, there you go, right? So it's a list of lists, right? But then if I want to make a copy, right, I'll have to somehow like get rid of these two brackets and just get these 3 raw numbers without any list around them. So the way I do that is this star, which is basically, it's called the unpacking operator. So then basically you think of it as exploding L and then getting all its elements and then putting them into M, right? So then this also does a copy, as you'll see. If I do this, right, 3, 2, 3, that was L, and then 1, 2, 3, that was M, right? And I can also do some pretty crazy things. Like I can do like L twice. So like this would be, M would be a 2D array and pointing to L twice. So right, everything is reflected when L is changed, right? And then what would happen here? So if I do this, now, can someone tell me what would happen if I do this?
Thinking it's just what came out last time without the brackets, with the extra brackets. Yeah, what Tarun said.
So let's describe M. Like after this happens, what is M after this happens? Like specifically.
On the chat, Tarun said something.
Oh, really? Let me take a look. Yep, that's exactly right. Right. M will just be a 1D array with 6 elements. And as you can see, there you go. Right, L becomes 3, 2, 3. M is 1, 2, 3, 1, 2, 3. All right.
Does it concatenate? Okay. Is that what the symbol is?
No. It means basically explode. Like, right. So if I
explode.
So going back to the previous example.
Called unpack, right?
Yeah, unpack. Like yes,
move the brackets around it. Yeah.
Yeah. So as you can see, if I do this, right, it's actually a list containing 2 lists within it, and each of those lists has 3, 2, 3. But then if I unpack like this, right, it becomes a single list. It's kind of like flattened out.
The values are not updated. The values are not updated from.
Right.
So it's unpacked. So it's kind of decoupling the object from the variable.
Right. Yeah.
The content from the variable.
Right. It does two things. One, it like unpacks it so it's like a 1D array, and then two, right? It makes a copy so that changes to L and not reflecting in M. So,
I see.
so yeah, I was just kind of building up to that with the different examples.
I see. Very cool.
Yeah. Okay.
I have a quick question.
Shoot, yeah.
So,
Yeah. What's up?
so like, if you just did like M equals star L without any brackets or anything, like what would M be? Like, what does star L kind of return, I guess?
Star L. Okay. Actually, I think this is not. So let me just test it. Let's find out. I'm actually. There you go. See, it's a syntax error. Like it's
You're
a
right.
yeah. Right. Yeah, because it doesn't make sense to have three bare elements assigned to M. Okay.
Yeah, can you hurry up a little bit?
Yeah. Yeah, I still have a little bit to get through. Okay. Functions. So let me do functions. So in Python, how do you find a function is define, right? You use the def keyword, and then you have, right, the function, which would be like, let's do func, just do like this, right? And then colon, like last time, and let's just say print hello. Crap. Let's see, hello, just hello. What? There you go. Right. So then let's get rid of all this. All right, we don't need this anymore. So if I just do func, this would be calling it. All right, and then this would be hello. There you go. First one's hello. Let's get rid of this. All right, hello. Right, and then to define a parameter, you just say, right, param, right, and this can be anything, right? So then let's do. So okay, in Python, like there's a similar thing to JavaScript's like backtick and $. Like if you want to print something, like for debugging or something, right? You do F in front of the first opening quote, and then you would do a curly brace, and then you stick in whatever you want there. So you could be like more realistically param, right? And a function, like you can pass in anything. This is on this. So if I do 5, right? So param would be 5, like, and then if I did it in hello, right? Param would be hello. So the function is like also like you can pass the arguments by name. So what does that mean? Like for example, if I do like I can do like specify the name like this, param equals hello, right? And let's do the same thing as last time. And then so there's a neat little trick you can do with this, but I'll get to it after I do dictionaries, which will be one of the last things I do. Because yeah, Tiago needs this time. If I have a dictionary, right? So in Python, a dictionary is just defined by like, so okay, that's it. So let's do actually that's another keyword, right? So let's do int to string, right? And then we have like one. You know what? Let me do string to int because that's more realistic with what you have in the lambdas. So if I do like a string to int, right, I can have 1, right, and that maps to 1, right? 2, that maps to 2, and so on, right? And the way you access a map, right? So then, say if I want to print, let's come this out first. So if I want to print, string to int 1, so the bracket, right, it will go to the entry with 1 as the key, and it will spit out the value. So then if I do this, right, it gave me 1 right here. And then the other thing you can do, like if you want to add a new entry to the dictionary, so let me just start doing the printing the string to int, right? So then if I want to add, right, so I could do string to int 3 equals 3. That's equivalent to just having declared it in there, right? So if I just do this, right, dictionary has 1 goes 1, 2 goes 2, 3 goes 3, And then I can also delete, right? So then if I do del string to int 2, that'll actually remove the entry for 2, right? So that when I print, it only has 1. And the thing is, like, just as you saw with loops, dictionaries can also be unpacked. So if I, for example, if I do this, string to int 2 equals, right, 3, 3, and then I do 4, 4. No, not there. Okay, and then if I do, right, if I just make a new dictionary, right, open the braces, unpack. So with dictionaries, the unpack requires 2 stars, right? Unpack string to int, unpack string to int 2. That will give me a dictionary with 1, 2, 3, and 4. See that this is a single dictionary with all of these. Now, like, you might ask, like, what happens if there's a duplicate key, right? Because like dictionaries are not allowed to have duplicate keys. So if I do 2, right, and to tell them apart, this will actually go to 3. The rule is that the last one will win. So if I do this, it should have 1, 1, 2, 3, 4, 4, right? There you go. And then one neat thing is that, like, the dictionaries are actually integrated into the language. So if I bring back function, right, if I can pass the parameters to it like this. So if I have params, I can have a dictionary. Then I have the name of the parameter and what I want it to be, right? And then I can actually call function with the unpacked dictionary with the params, right? And that will be equivalent to what I had previously with like that. See, like, that will be equivalent. Wait, what's going on here? I think this is highlighting. Yeah, there you go. See, so this first call, right, is what you saw previously, where function called with 1 and then it prints. And the second one is where the parameter is actually inside this dictionary, and I unpack it and send it to the function, which basically comes out to be this, and then that gave me the same thing, right? And then the last thing to finish up before I let Tiago do his thing is type conversions, right? If I, for example, this is an example of something you might encounter. So if you have a URL path parameter that had a string, right? So let's do path equals 1, 2, 3. Then your database actually has that as an int, right? How would you make it an int, right? So then I would do int path equals int path, right? If I do print int path, there you go. This is actually like.
How do we know we're not printing the other one?
So let me add 1 to it. There you go.
Okay, yeah, that
so
works.
There you go. Let's add 1. So then it's 1, 2, 4, right? And likewise, you can go from int path. I mean, the print function automatically does this, but like, you can explicitly do the string of int path, and then it will just go back to a string, and just to show that's not an int, if I do +1, right, it doesn't work. There you go. All right. Any questions? Okay. All right. Yeah. That was just a crash course on Python. Yeah. Like, if you have any issues when you're actually writing your lambdas, like, feel free to talk to me about it. Like, I'll be happy to help you out. And yeah, I hope everyone got something out of this.
All right. Thanks, Eric. Now we're going to move on to some basics of databases, and then we'll write, if we have time at the end, we'll write some more Lambda functions to get used to it a little bit more. And hopefully we can finish this, but otherwise I don't know, we'll do the Lambda functions. We'll just start the next meeting with them. Okay. Databases 101. So first of all, this is just a bit of a review of the stuff that we did at boot camp, but there's tons of types of databases, right? And the most popular databases are relational databases. And we can see that by checking out the school website called dbengines.com. And they have the rankings of all the popularity of databases, right? And if you guys take a look at this pretty quickly, you can see that the 4 most popular databases are all relational. And then out of the top 10, we have 6 relational databases. So it is very popular. Here's our friend DynamoDB on 16. This is kind of subjective, so like it's not. Don't take this list to be like fully accurate, but it is pretty accurate. And as you guys can see, there is relational and non-relational. And as you guys can see, the non-relational databases have multiple different types. There's document, search engine, key value, multi-model. So DynamoDB, if you guys thought it was key value, it's not. It also supports document type, NoSQL. So yeah, these are the most popular databases. A lot of your favorite apps are run on these databases, and DynamoDB is of course also used. So let's go back here. Now, relational databases work under this this acronym called ACID, which is atomicity, consistency, isolation, durability. And I have a quick link from Wikipedia here that kind of describes these concepts. I think, wait, did I write about these here? No, I only wrote about base. So let me read these off of here. So you can check, actually, these slides, I actually left a lot of links. So I'm gonna post them, and I highly recommend you guys to check these links out. But I mean, I think these three concepts are pretty like self-explanatory. So I'll read out the atomicity, which is just that transactions are multiple statements, and this concept guarantees that each transaction is treated as a single unit. So it either succeeds completely or fails completely. And what this allows relational databases to do is to be more reliable, and it makes sure that you always get the very, very accurate data, and it never returns it never returns an approximation of data, and it never returns something that is not 100% true, which we'll see later. So what is the cost of having all of these things be part of relational databases, right? So you have to be consistent, durable, and you have to have these concepts that make sure your data is always accurate. And you'll see later in the CAP theorem that these features come at a cost of performance, latency, storage, and throughput, which I think I shouldn't have put this here. Should I put this later? But as I move on, I can come back to this slide and talk about why these might be costs of running a relational databases that has these benefits, right? So non-relational databases, also called NoSQL solutions. Some popular ones are key value stores, which is DynamoDB, along with document stores, graph databases, time series databases, search engines, multi-model. There's plenty of those. They're actually listed out in popularity order in here. So the most popular ones are key value and document, and then the least popular ones are search engines. And the non-relational databases, also NoSQL, are follow this, as you guys can see, it's kind of like a pun, right? Acid, base. It's kind of like to help you like remember things. So basic availability, soft state, and eventual consistency. So basic availability means if you're gonna try to get the data that you have available, but you're not worried too much if it's exactly the perfect data that you wanted. So same thing with soft state and eventual consistency. So the database has to be consistent eventually, but like if it's when you make a call, it can still be like fluctuating from previous calls that you made, and you're okay with that. And that lets you have a much faster latencies when you're making calls to write and read, and it makes it a lot cheaper to scale out, which we'll talk about scaling up versus scaling out in a second. So relational versus non-relational. Relational engines require consistency at the end of each transaction, where non-relational engines only require that the database be consistent at some point in time, eventually. So now, what should you choose? Relational databases versus non-relational. So this is very, very, very complicated. And a lot of the time you can't really there's pros and cons for both types of databases. And it's hard to say that one's better than the other for every use case. There's always, for different use cases, there's one that's better than the other. And for some use cases, neither is better than the other. And from some other use cases, both is better. We'll talk about that later, how a lot of companies nowadays are using both NoSQL and SQL to databases to be able to, have a better product and have the pros of both types of databases without too many of the cons. So now I want this to be a little bit interactive so you guys kind of understand this a little bit better. Now let's think about some use cases. What do you guys think you should use in general is used in, what kind of databases are using in banking and why? If no one volunteers, I'm gonna just choose someone.
Probably like a relational one that uses ACID. Has to be like very precise, right?
Yeah, totally. That's 100% it. Because in banking, you need, most of the time you have very, very sensitive information that you're passing around and storing, and you do not want to have one single margin of inconsistency, or you never want to be unsure that you're getting the exact data that you want, right? If someone if someone just made a call 1 millisecond ago, 1/10 of a millisecond ago, to change the data that you're retrieving, you want to make sure you're gonna get that, or you're not gonna get anything, right? You either get exactly what you're expecting, or it's gonna get mad at you and you're just not gonna get anything back, and then you're gonna make another call, and until you get the exact data that you want. But what about accounting? Can anyone tell me what you'd use for accounting and why, in general? All right, Tarun, you tell me.
Can you go back to the slide that had base on it?
Yeah, sure. Here, I have a better link for you. You guys should definitely check these links out. Here's basic availability. The database appears to work most of the time. Soft state stores don't have to be write consistent, nor do different replicas have to be mutually consistent all the time. Remember how I told you guys about secondary global indices? So they're mostly consistent. They're clones of each other, but they don't have to be consistent most of the all the time. So you get that speed. And eventual consistency. Stores exhibit consistency at some later point. Just take a guess. It's fine.
I think you want relational because you would like the same thing. You want to be accurate.
That's a good point, and I'm sure a lot of I'm sure it's used in accounting, but for the most part, accounting uses for the most part they use non-relational databases, because just as a concept here, we're talking about data that can be it's okay to you're gonna have thousands of numbers, and it's okay to make some in accounting. It's okay to make estimations here and there, because that's a lot of accounting anyways, and it's not as info sensitive as banking. And you can actually read about this. I think in here. Do they talk about this? I think they talk about, I don't think I put the link in there, but I'll put the link later about banking versus accounting, and relational versus non-relational. It's actually pretty cool. Now, scaling out versus scaling up, right? Scaling out means adding more components in parallel to spread out a load, and scaling up means making a component bigger or faster so that it can handle more load. Now, which one do I'm gonna can someone volunteer and tell me which one do you think is used mostly by relational databases and which one is used mostly by non-relational databases? I actually talked about this in when I talked about DynamoDB last time. Satya, you there?
Yeah.
Give me a guess.
Is relational scaling up and non-relational scaling out?
Yep, you got it. Non-relational is scaling out, as I told you guys. It's also called like a horizontal scaling versus vertical scaling, right? And typically, 100% of the time, pretty much, scaling out is cheaper and faster and easier than scaling up. So scaling up, to give you guys an analogy, for my desktop, for example, I'm running on a desktop right now. Scaling out would be, I mean, this is not a very good example, but let's just use this anyways. Or let's just use like a server, for example, right? Scaling out would be you get a server and you have, let's say you want to have a database with 200 terabytes of data, right? Scaling out would be having, 20 modules of 10 terabytes each. And, buying, 10 terabytes is not cheap by any means, but it's certainly a lot of the time cheaper than buying one 200 terabyte, like one system with 200 terabytes in it. And that would be typically more expensive. And also when you take into account how much data, when you have 200 terabytes in this one disk, it is actually, when you want to retrieve something from that disk, it's very likely that it's going to be slower because you have to sift through all the 200 terabytes of data when if you have your data correctly organized into these different modules, it would be typically faster. But you can't just say that it's easier to scale a non-relational database and for it to be faster than a relational database. That is actually that's not factually true. There's plenty of relational databases that are very fast, and I don't know about the cost, but there are plenty of relational databases that are just as fast as non-relational databases, but they're typically harder to build. They're just it's just like the characteristics of non-relational is cheaper and easier to scale. But there's definitely fast and scaled out relational databases. Otherwise, of course, we wouldn't be looking at this and saying 4 relationals in the top 4, right? Now, the CAP theorem. Now, what the CAP theorem says is you can, you have these three things that are big aspects of databases. You have consistency, availability, and partition tolerance. Consistency means that any read request will return the most recent write. And by the way, all of this that I'm showing you guys is very, very dumbed down. It's not damn it. It's just very surface level and very simple because this is databases 101 in 40 minutes. So I'm trying to make it as simple and as understanding as possible, but databases are very, very complicated. UT has their own course on databases and they talk about it for a whole semester. So, and it's taught by someone with a PhD. So I'm doing my best to talk about databases in 40 minutes. But so, of course, consistency is the real definition is not just one line, but I'm trying to make it as simple as possible. Availability means non-responding node must respond in a reasonable amount of time. And partition tolerance means whether the system will continue to operate despite network or node failures. So, one second. So what the CAP theorem says is that you can only have 2 of these 3, right? So you can only have consistency and availability, or consistency and partition tolerance, or availability. And you can only have 2 of these. You have to just pick because let's think about this for a second. If your system needs to be available and partition tolerant, then you must be willing to accept some latency in your consistency requirements, right? So, it's just going to take longer. Now, if you're, let's say you have to be consistent and partition tolerant, right? That means you have to be consistent and partition tolerant. So you have to, every time you make a call, right, you have to wait till the system is fully ready to receive your call. And you know, if you make the call immediately, the data they want might not be available, so you have to wait for it. And same thing for all the other things. Like you can have the logic in your head how like two things, like if you have two of these things, it's really hard to have the third. Now, can someone tell me what kind of shoot, I shouldn't show that. What kind of databases? So for relational databases, which two of these three do you guys think is they focus on? Of these three things, relational databases, which two are focused? Consistency, availability, and partition tolerance. Someone? I'm gonna call someone.
Consistency and partition tolerance.
So consistency is right, but for relational databases is really important. For relational engines, it's really important for you to have availability because so let's say how am I going to explain this? Relational databases are built upon having readily available and consistent data. And what partition tolerance normally implies is that your system will continue to operate despite network or node failure. So in a relational database, if you make a call and let's say you're not ready yet to give that data, or you make that call and that causes it to fail. In a relational database, in a non-relational database, what's going to happen is you're just gonna get the data that is like, the data is not available yet. You're just gonna get the data that was like most recently available, right? You're gonna get the data that was most recently available. But in a relational database, you're not gonna have that kind of situation. So here's like some two little schemas that might help you understand this. Non-relational engines are used for both these two sides of the triangle, and that's why there's so many of them. If you check this out, most of them are not actually there's a ton of different non-SQL, like NoSQL databases, and there's multiple types of them, right? There's the document, I went over, there's document-based, where is it? Document-based, key value, there's plenty of them because they're filling a lot of the space here. And you guys can see here some of the consistency and availability side here. These are all relational. The Oracle, as you guys saw, the Oracle database, MySQL, PostgreSQL, SQL Server, these are all relational. And then MongoDB, it's NoSQL and all that stuff. Dynamo is also down here, partition tolerance and availability. Now, let's talk about a little bit of non-relational databases. So let's talk about key value non-relational databases. So let's say, so when do you want to choose a key value non-relational database? Typically when you have a simple schema, you have many reads or writes and a few updates. And as we talked previously, these databases will scale across many nodes and perform well. So they'll be cost efficient and they'll be well performing. And you don't want to use them when you have too many complex queries that require joins. And some examples of these are DynamoDB, Cosmos DB, and Redis. And some companies that use key value databases. And of course, none of these companies use exclusively this. These companies use a plethora of databases that have different, they're huge companies that use multiple kinds of databases. But from what I found online, Snapchat and Netflix do use NoSQL databases like this. And I wasn't aware of Lyft, but I was told last week that they use that. So that's really interesting to know. And here's a quick slide about document databases. You might want to use them when you have a flexible schema instead of just a simple schema. You have balanced read to write ratio, high read performance, and here are some of the databases that that are document based. And I think also Google, what's it called? Firestore, Cloud Firestore, I think is document based, right? Mehul, you've used that before, right?
Yeah.
It's document based.
Mhm.
I'm pretty sure. Yeah. Cloud Firestore also very popular in hackathons. All right. Now we talked about all these things that you need to consider when choosing what database you're gonna go with, and these three being the most important aspects. But these are not the only things you probably want to consider. Many other things when we're thinking about a database. So CAP, of course. Now, disaster recovery. So you want to know if the database that is, the service that's providing your database, you want to be sure that if things go bad, you can have a backup. So in Dynamo, you can actually, when you go delete a table, you can actually create a backup. I don't want to do this right now because I don't want to risk this, but I've done it before. I deleted our users table because I needed to add something to it. I don't remember exactly what, but in Dynamo, you can actually make a backup when you delete the table, and you can bring it back from the dead, and it's really nice. What else do you want to consider? Performance, cost. These are directly related to CAP. And also you want to consider complementary technologies, infrastructure options, vendors. You want to see exactly if in paper, it can be a really nice database, but if you don't have a nice way to interact with it, if you don't have nice infrastructure around it, then it might not be so good. And also monitoring and alerting. That's what CloudWatch is for, but that is for Lambda. But there is many services that help you know exactly what's going on with your table. They'll let you know, they'll let you know when things happen. So for Dynamo, we have events, and I don't think we're actually monitoring it right now because that costs money. So, and we don't care that much, but yeah. And so we talked about all these databases, but if you can't choose one, that means a lot of the time you're not supposed to choose one, because complex systems of today require multiple database engines to provide efficient solutions that a single engine cannot. And then major database vendors are adding cross-functionality support for both for backend systems that they interact with both relational and non-relational databases. And of course, that makes it so nowadays there's many engines that are similar to one another, and it's hard to even distinguish what kind of database it even is, because there's so much going on, and it's such a complex system with so many different types of databases. And here are some links that you guys might want to read over, because this was a 30-minute Databases 101, and I know there's probably some confusion. So I will post these slides in the Slack, and you guys can check them out. Now, let's move over to some Lambdas. Do you guys have any questions? All right. Now that we talked about databases for 30 minutes, let's go over some ways to interact with databases, which is Lambda computing. So if you guys remember, we wrote a get and a post last time. So today I want to do a review on a get and write a new get function, right? And I want to show you guys how to update a row, and I want to show you guys how to actually query by secondary global indices, because we talked about it last time, but I didn't show how it works in practice. So I want to show that. And I also want to show you guys how to delete a row in your table. Let's do that. Cool. Let's start with our quick recap of how to, let me make sure I have API Gateway open so we can quickly test these as soon as possible. All right, we're ready. All right, let's write this. Now, there's one step in the beginning of every, you know what? So this was a get that I wrote using without path parameters. So it was actually, I should have put this in, I should have had path parameters for this to actually get, but instead I don't remember why, but I wrote this as a post. So what you do in a post is you send things in the body. So we're getting our data here. You know what? We should probably do our get medicines again. Do you guys remember how to write the how write a get method, or do you guys want me to review it?
Can you review it?
Yeah. All right. Let's write the medicine one again, because sorry, the medicine one, not the recipes one, because I don't want to write this one because this is kind of not optimal. I want to make sure I write some good code for you guys. So let's go over here and let's write this. Let's write this one. Yep. Let's delete this. Hopefully I remember it. Okay, let's write that one because I don't want to show the other one's not very good. Let's do this one instead. Hold up. Okay. Get recipes. Okay. If I remember correctly, we first have to get our item. SD table get item, right? As you guys remember, the get item is going to be used every time you have a get method because you're trying to get something from the table. And do you guys remember what I need for getting something in a DynamoDB table? What do I need to give it? What parameters do I need to give it?
You need to give it some sort of condition, right?
You need the key, right, to get the values?
Yeah.
Yeah, you need the keys. So yeah, you were right about that in here for the get recipes, because we're filtering when we get multiple things and we want to filter for just title and our recipe ID, then we need to give it like the parameter conditions. But since here we're not getting everything, we're just getting one recipe, right? The thing we're writing right now, where is it? Yeah, we're just getting one recipe. We're not gonna do this. We're just going to give it a key. I think it's good that I reviewed this. So we're gonna give it a key. As you guys remember, the key is the recipe ID, and we're gonna give this key in our path parameters. I actually have you guys over here. Let me minimize you guys. So okay, there you go. I actually have I have to pick up this key from the path parameters that is going to be sent in our. If you guys are not familiar with the path parameters, I'm not sure if I explained this before, but the path parameters is just part of the endpoint that like you're going to be requesting, and the endpoint's going to have like whatever ID that you want. So let's do that again. So we're going to grab that from our path parameters. Whoops, and then we're going to have a recipe ID. All right, pretty straightforward. And also, we want to make sure we get, our table. If you guys remember, our table in is actually has recipe IDs or numbers, right? And we want to get by recipe ID. So we have to use one of the things that Eric showed us earlier to make sure we get by number and not by string or whatever. So we have to wrap this around this. Yeah, there you go. I think that looks decent. Then we have to, so we're getting the recipe. When we're getting a recipe, we want to get our ingredients, right? And we already have the title and we already have the content. So let's do another thing that Eric showed us today, which is using the list constructor to this is going to be a list here. So we're going to set our recipe items. So whenever you get item, the very outside key becomes items. So you have to index into items, right? And then we're going to index into ingredients to set it to, we're going to use a list constructor here to make sure it's a list. So we can return it later.
Wait, yeah, we don't need this anymore. I don't know what version you're looking at.
Wait, what? How come?
It had something to do with whether you're scanning from the table like object or whether you're scanning from like the client object, and then basically if you scan from the table, it does the conversion. Like you don't need to do that.
Wait, why do you not need to do that again?
Because
we're unpacking it now. Okay, let's right. Wait a minute. We
no,
do need
you don't
it.
need.
You sure?
Yeah, we don't. That was old. That was from when it was really bad.
So we just return now.
Possibly, yeah.
Okay. I mean, I thought we needed this, but Eric's saying we don't. So let's see what happens when we try to return it without that. So we just return, and we have status code 200. All right. We have. We're not gonna worry about headers. And we return body. We have to parse into JSON. So JSON dumps recipe item, right? Yeah, that's what it's called, recipe item, because we have to index into it. And then we have to have like the boilerplate here. Okay. You think this is it, Eric? Eric?
I think missing a brace at the return.
Yeah. I thought we needed this. Well, my bad. Do we have two of these? No, we only have one. All right, let's see if this works. Oh, my bad. It's not this one. We want to check APIs, bootcamp, recipe ID. All right, let's get 5. Oh, it did work. Okay, my bad. Eric, you want to explain why we don't need that anymore?
Because basically in JSON, like you can only have lists. There's not a notion of like a set in JSON, and I think somehow it was getting turned into a Python, because in the database in DynamoDB there's a thing called a set, and I'm pretty sure there was some kind of thing that happened with this client code that made it turn into a set, and then when you try to serialize that set, right, it's not going to work because in JSON you can't have sets. So then that's why you need to turn into a list and then try to serialize that list to make it work.
Yeah, that makes sense. All right, thanks, Eric. Okay, so that worked. Let's move on to the exciting stuff, which is new stuff. This was just review.
One question.
Yeah, go for it. Oh, I just.
So we're like, when we were writing the last time, we were like testing like account information for doctor for CloudCare. You like in an API gateway, you pass it in the event body.
Yeah,
But-
I can. You want to know why we have to pass it in the different thing here?
Yeah, basically, like how does
Yeah.
it know to give you like
Mhm.
the little box with recipe ID?
Yeah, totally. So in a get method, right? You'll have path parameters, right? But in a post,
So you can post. Okay.
you don't have like we don't necessarily have to pass in our path parameters. So let me show you what the bootcamp one looks like. So here, since this is a get, do you see anywhere to have the request body? The request body is not supported by get methods, right? You can't put in anything in body. You can only put it in the path. But for a post, no path parameters exist for this resource. You can define path parameters by using this. I don't even know what this is, right? Essentially, you can only have path parameters in a get. You can only have a request body in a post. That's the gist of it.
I think you can have both in post.
Yeah, both in post. Wait, how come you can't do it here?
Because that's not the way we set it up for this specific post method. We didn't define any path. Like it's in the YAML file. You have to define which
Oh.
endpoints have path parameters and which don't.
Oh, so you can give it path parameters if you.
Yeah, this is what this is saying. Yeah.
Okay. All right. Well, there it is. Okay. Now let's do the what did I plan to do? I plan to do our update, right? Update. Okay. So we need to write update. So updates is going to be a post because we're modifying things in a table instead of just getting. So in a post method, as we established, every time, let's get this out of the way here. So we don't have to look at it. Okay. In a post method, we established that we always going to load our request body first. Events body. So now we have our request body, and what is in here? I'll give you guys a little bit more background on what this method is doing. In our app, we have each patient has a plan with multiple medicines, and to be able to update these medicines, we need to know what user it is and what are the medicines that are going to be the new updated version of them, right? So so what do we have in our event body that we need? We have our medicines and we have the user email. And those are the things that we're going to use to create our, to update our table. So in Lambda with Python, so Boto3, we're going to call update item, just like a get item. It's pretty intuitive. And we're going to give it the key that we need to update this item. And of course, as I just said, is just the email of the user. Is just the email of the user, right? And what else do we need? We need other. So one thing that is really annoying for this code that I'm about to write is that the keyword plan is actually a reserved keyword in DynamoDB. So we can't use it as like, we just can't use it. So we have to set, I'll show you guys how this goes. So our update expression, you guys can know all about update expressions. Wait, I had the link, DynamoDB. You guys can type in DynamoDB update expressions and you can read all about them. There's a lot of weird syntax things that you need to know. But for our update expression, it's going to be as a set, right? So in an update, you can do a set, a remove, a add, or delete. But this time we're going to be doing a set, right? and we're gonna set our plan. You guys will see why I have this hashtag PLN here is because, as I said, plan is a reserved keyword. So I have to do this annoying thing. And we're gonna have our expression attribute values, which is we're going to give our val1. So we're going to set plan to val1, right? And what is val1? Val1. So let's just say val1 is our medicines, right? The medicines that need to be updated. Can someone tell me where the medicines are coming from? The new medicines. The new medicines I'm going to put on the table. Where are they coming from?
From data.
Yeah, exactly. Thank you, Mehul. They're coming from data. So we're gonna go with data, and it's actually called medicines, like this. And then this last line, you probably gonna have to do unless you have this annoying thing here. So what we have to say is hashtag PLN is simply equal to plan, right? We wouldn't have to do this most of the time, by the way, guys. We would most of the time just say plan in here and we'd be done with it. But yeah, it's annoying. It's a reserved keyword, unfortunate. So now we've done our update. Now, if this worked successfully, this update item, that means we're gonna return a status code of 200. So status code 200. You know, same stuff as before, headers, body. Now, a little bit more interesting stuff, body. I have to do JSON dumps to serialize it into JSON, which is the way that we pass data around with, HTTP requests. I'm gonna just call it update, and I'll pass in the update, and we'll have this.
So do we ever use the return body for anything?
Headers?
Or do we just ever use the status code?
The return body?
Yeah, do we ever like use it? Or do we
Yeah, for sure. In our front end, for example, I mean, I don't think in this case I use it. Do I use it? Yes, I do, totally. In what a lot of the time that you do, for example, in my code generator, right? We will return, so we'll generate the code in here in the front end, right? Sorry, in the back end. And then in the front end, it'll return the code that it generated, right? So let's find this. So JSON response, right, is our JSON, the decode response body. And then our code is going to be equal to our JSON response code.
Gotcha.
Do you see how that works? We return the code that we generated, and then we use the return body. All right?
Got it. Thanks.
Okay. I wanted to actually write the GSI query. Well, let me test this first. But I think we'll just leave that for next time since it's already 5 and my mouth is already dry from speaking so much. I deployed, what is this called, guys? Update medicine. Let's see if it works. Update medicine. What do we need to give it again? We need to give it email, right? Email. Let's do t@gmail.com because I know that's a user. And we need to give it a plan. I think the plan is in the plan is a nested dictionary. Oof. Okay. Let's just change it. Let's just copy one of these. Let's copy one of these. Yeah, so it's an outside map with 3 Okay, let's just change it to this. AHA M custom, because each medicine. So it's really hard for me to test this because each plan has different medicines. Then they each have their own map. So I'm just like I'm not gonna be able to write a whole map to test this. But I am pretty sure this is correct. Eric, do you see anything that's immediately wrong with this?
Final race after return.
Okay. All right. Otherwise, I think this looks good. Yeah, it's really hard to test this with right now with like just typing stuff into here because it's like a map of maps, so it's hard. But okay, we will do a query by GSI next time, and we'll also do a delete next time, and then we'll start the lecture on authorization authentication. I mean, unless you guys do you guys think is valuable for me to show you guys a query by SGI? Wait, GSI, or do you guys think you can figure that out on your own and you just want to like learn? Like next week's supposed to be authentication and authorization. Do you guys want to see this or should I just skip it?
I guess that would be helpful. I don't know.
Yeah,
I
Yeah.
that'd be
think
cool.
understanding GSI as a concept should be really easy, and implementation we can just figure out ourselves.
Yeah. Okay. All right. Next week, I think I'm not sure if I'm speaking next week, but I think Neil and Eric. I think Neil hasn't been here in a couple weeks, so he's probably going to be speaking. But yeah, unfortunately we weren't able to finish. But I think that You know what? I will post with the slides. You know what? I'll do that right now. I will post in here. I will just add a few slides with the screenshots of how to do it. All right. So, all right, guys, thanks for coming. Anyone have any more questions? Yeah. So yeah, I'm just gonna do something like this. Query by GSI, and I'll just do something like that. All right, I'm gonna go ahead and end the call. See you guys next week.
Thanks.
Yeah, thanks for coming.
Thank you.